Good afternoon. So the title is to rag and not to rag. Since everyone's showing up here, so I assume everyone have heard this term rag before, or so retrieved augmented generation, which is one of the most adopted AI in enterprise. Right? So even though my talk today is focusing on the financial service industry, but it's a similar environment in the highly regulated industry like healthcare, pharmaceutical, you will probably have a similar landscape as well. So here is the agenda for today. I'm going to just go over the regulatory landscape in the financial service industry, the SEC and the FINRA. And then we'll take a deep dive into the RAG architecture. Then we'll focus on the debate whether use a RAG or with the latest large language model with a very large context window, all the way up to 1 million tokens. Like, why do we need RAG? Then we'll conclude with some best practices in how to scale AI safely in an enterprise. So Fidelity Investment, so it's a company probably everyone's heard about. This company founded 80 years ago, and today it becomes one of the largest financial services in the world. So you probably know Fidelity from mutual fund, but also 401k, as well as we also do brokerage services. So there's a free commission trade with Fidelity as well. There's a crypto as well. So we do a lot of ETF, index fund, etc. So we serve individual investor, workplace participant, and institution as well. So such a broad customer base. So any small issue with whether it's using AI or not, it can become quickly a largest risk event. Right? Here's some of those numbers to put the scale of Fidelity into perspective. Right? We have 60 million customers, and we have $18 trillion under administration. So just out of curiosity, so everyone here, raise your hand if you have a Fidelity account. Wow. So there are a lot of Fidelity customers. So I need to be careful what I say next. But it's just kidding. So my presentation already reviewed by legal, by compliance. So I'm not going to share anything that's confidential. So in terms of scale, one of the issue that we are trying to apply AI is on the customer service. So just to look at some of those mind-boggling numbers. So last year, we handled 40 million phone calls and have more than 43 million digital engagements. So how do we use AI to serve our customers in such a large scale? Right. So today's conference is in terms of AI landscape, just every industry, financial service industry included, everyone is heavily invested in AI. Right? So just a few years ago when the ChatGPT first came out, so everyone is doing experiment to chat with a PDF file. Now we are embedded almost everywhere, the Gen AI in the operation, including financial services. If invest Gen AI, how to pursue, improve the company operations efficiency, or investment term we like to call alpha, right? Where if you get the risk-free return is called alpha. But however, there is always a barrier. There's a black box nature of LLM is always a barrier for full adoption. So here is the the main discussion today. So there are really two central questions. In a highly regulated industry like financial services, can we safely adopt Gen AI? You probably can say the same thing with other industry that dealing with a massive amount of customer, whether it's healthcare or pharmaceutical. They are heavily regulated, right? How can we apply Gen AI safely in such a regulatory environment? And the second question is, RAG has been considered almost the gold standard to apply AI in an enterprise. But now, the latest large language model, they all support 1 million tokens in the context window. Do we still need the RAG, right? So that's the 1 million token window eliminate the need for RAG. So those are the two questions we're going to discuss today. Right, let's look at the first part. Look at the regulatory landscape in the financial services. So for those of you that are familiar with financial services, there are really two agencies, right? The SEC, which is the federal agency, and then the other one is the FINRAG, or Financial Industry Regulatory Authority, which is a self-organized industry organization. For those of you that if you think you have built an AI in the stock trading, say, for example, you find an amazing opportunity, you're going to beat the market. Great. You're going to sell your service to other customers. What's the first thing? You need to get a license to become a broker. And where do you get a license? You get a license from FINRAG. You need to pass the Series 7 exam. And so all those regulatory agencies, they are catching up as well. They are slowly to adopt the AI, and they are updating their regulation, though there are a lot of unique risks posed by AI. Right? So if we look at SEC, they focus on 3 areas. One is disclosure. So if any advice is generated by AI, you need to explicitly disclose the market. This is AI-generated advice. Right? And you need to have a full audit. Right? Those prompt and the response, they need to be immutable and fully audible. And as well as make sure that your AI-generated advice, they are fully aligned with client's interest, not your corporate interest. For FINRAG, they really focus on the other 3 areas. One is on that you're not using AI to do fraud, right? In security, one of the fundamentals is return and risk, right? High return often accompanied with high risk, right? Low risk, then you have low return. So those are the 2 things. You can say you want to advertise, I have an amazing investment opportunity, very high return. But then if you downsize the risk, that will be an issue, right? Versus the other one, if you said this is low risk, but then there's, the return is not associated, disengage. This is where this is coming from. You cannot just blame this is just a hallucination, right? So that is a more of the fraud rather than a bug. So that's where SEC and FINRAG actually really monitor this. And you need to have a supervision as well. So you cannot just say this is just AI generated, but you need to have a human. You need to have a supervision. And privacy as well. Any of the PII data, you cannot just send your customer that identification through the internet, through the LLM. In wealth management, everything that need to be audible, traceable, you cannot say maybe. Say hallucination is really a big problem, right? Someone pointed out, hallucination is not just a prediction error. It is rooted in your design. So it is of an issue with your design. Okay, so let's take a quick, assume everyone is familiar with the RAG architecture. We'll just go through this quickly. So fundamentally, the large language model, they're trained on general knowledge. The model doesn't understand your company's specific internal procedure and policy, right? You need to augment it with your company's policy and procedure, as well as the latest news, changing latest filing, right? Those are not in the training. So you need to augment it with those information. And that's dealing with, so there's typically the two pipeline, how to get your company's specific information into a vector database. That's ready for consumption. And then in the real time, there is an inference pipeline to consume that information. So we can take a quick look at each of these two pipelines. In the ingestion pipeline, right, there are really 4 steps in the pipeline. The first, you need to have a set of connector to connecting to your company's data sources, whether it's structured or unstructured data, whether they scatter around everywhere, right? Whether it's if your company uses some wiki tools like Conference, you have a lot of documentation, or if you have an internal website, have a lot of documentation, as well as structured data stored in some SQL database somewhere. You want to connect all those data sources together to leverage those knowledge for your AI application. Then you need to have a connector to connect them to all those data sources. Then you need to do some pre-processing. Right? A lot of the text, especially the text data, initially you build it is for human consumption. Now you need to make sure that those information is well understood by an AI. So you need to pre-process them and do the chunking. So the chunking part is a phenomenon when you need to do the embedding, which is a language model convert the text data into a set of numerical vectors so that it can mapping the meaning of the language into some numerical vector. Then later on, when you perform the search, it can perform what's called a similarity search. And the reason we need to do the chunking, because each embedding model, it has a certain token limit that can understand the meaning, right? Whether it's by those dimensions, right? Initially, I think when this a few years ago, when the embedding model started, it started like 515 token. Now it's become 1,000 token. Now it's all the way become, I think most of those leading models, 4,000 tokens. So those have a token limit. You need to put the document, a long document especially, into multiple chunks. Then creating those vectors, put it into the vector database. Now, once you have all your data in the vector database, you can consume them in real time in an inference pipeline. Right? From the end user, have a question, you submit a question, and this is critical. So the first thing you need to do is to do some query optimization. So as Don mentioned, so my background is in optimization. So this is my passion, right? So really want to optimize the user's query. The user can submit all kinds of questions. You could have a spelling error, right? You could have an acronym. You want to expand it. You could have the same thing that you want to translate to the right terminology that map to your corpus in the data. So those that will help the search algorithm to find the right content. So you want to do that in the, and earlier, Don actually have a really excellent talk for those of you who missed the talk, probably connect to Don about using small language model. And this is query optimization is a very good place to use a small language model. Okay? So you want to have a really fast understand, translate users' query to a language that's good for the search engine. Right? In the search, you can have typically the best practice this day is what we call a hybrid search. Combine the lexical search and semantic search together. And then the semantic search is the one that we mentioned earlier. You build the ingestion pipeline, pull your data into the numerical vector, put it into the vector database. And that's for the semantic search, where it connecting to your vector database, find out the right information. Right? Then the traditional keyword type of search is called lexical search. There's an algorithm which is called the BM25. And this is semantic search, so really they work really well on most of the cases, but there are certain cases lexical search actually can perform better than semantic search. So you want to combine the best of both searches, and then you need to use an algorithm to combine them and do a re-ranking. And that's another good place to use a small language model to do re-ranking. Right? And that's really the secret sauce for Google, right? Google, they really have a good ranking algorithm called PageRank. And that's where their secret sauce is in the re-ranker. Then you put those top K, whether K is of 5 chunk, 10 chunk, or 20 chunk, depends on your use case, right? You put those into your context engineering, put those into LLM, then combining with your system instruction for the LLM, then you generate the initial answer. And for a regulatory industry like financial services, that's not the end. You cannot just present the answer to the end customer. So you need to go through the process, the guardrail, right? So check whether there is any compliance issue, whether safety issue, and whether it's a factual grounding. So whether the answer really derived from the context you provide, not from the something from its training knowledge. So you want to put the system instruction, make sure that it's put it in priority, right? Start with the context you provide. If the question is cannot be answered in the context you provide, you have a choice whether you want to reject the answer immediately, right? You don't want to answer this question. Sorry, I cannot find this question in the context you provide. So that's often the case for the safer answer. Or you can rely on LLM's training knowledge to answer the question. Okay? It depends on your use case. Okay, now let's get to the main part. Right? So do we still need RAG? Right? Now all those LLM, they support 1 million token context window. Right? Google Gemini, they really started having the context window as large as 1 million tokens. And Anthropic Claude, I think just a few weeks ago, they just made the Claude Opus 4.6 and the Sonnet 4.6 from the beta version of 1 million token to production now. And OpenAI has been resisted to increase the context window. I think for those of you who follow OpenAI model, they started just 8K context window, then 128K for a while, then 200K, then 400K. I think just about 2 weeks ago, March 5th, when they released GPT 5.4, that's the first time they supported 1 million token context window. So now it's the question. It's all those leading large language models, they all support 1 million tokens context window. Why can't we just throw everything into that context window? versus when you build the RAG, as we showed earlier, there are a lot of infrastructure set up, right? You need to build your connector, you need to build your ingestion data pipeline, you need to have a vector database, right? Versus, I don't need any infrastructure, just throw everything into the LLM context. So the first thing probably you encounter is economics 101, right? It's cost. So when you throw everything, that your token consumption will increase, and your cost is based on the token consumption. Versus a RAG, those retrieval, you find the right context, and you feed the LLM with the right context, a small amount of context. Then the second issue is the latency. So because the context window is so large, LLM need to read through the entire context. It takes time. If a typical comparison between, say, the RAG, the first time to token, first token is about 2 seconds. Then it started to produce answer. Versus if you have a very large context window, it can take as long as 45 seconds to get to the first token. Then this part probably is the most important one. Like in terms of the trade-off between RAG and the large context window, there is a loss in the middle phenomenon. I don't know how many of you heard this term before. What it means is if you have a very long context window, the LLM pay attention at the beginning of your context and at the end of the context. Those that really pay attention. Those in the middle, kind of somewhere getting lost. Right? You just have too much information, right? Especially if you have a conflicting information. So those in the middle will get lost. And so if, for those who follow the OpenAI's announcement that on March 5th, when they announced GPT 5.4, in the long announcement, there is one small benchmark. They did show this. Right? When they announced the support of 1 million token context window, so they released the benchmark they did. Right? So one benchmark data for the graph walks, when the context window is below 128K, then the accuracy is 93%. That's great, right, for that data set. But then when they increase the context window all the way to 1 million, it's dropped to 21%. So it's not always the more the better. It's whenever the context window increases, you're going to get a regression. Right? And in another, for those regulatory industry like financial services, this is very important, auditability and governance, right? So when you throw everything to LLM, there is no access control. Versus you do RAG, then you control what data you give to LLM, and whether there is any data masking needed, you will have a control before you feed the LLM. And former SEC chair put this quote, I said, a duty of care and a duty of royalty apply regardless of whether the investment advisor is using AI or not. So if we compare the RAG versus a large context window in this radar chart, a large context window really excel in terms of ease of use. Right? There is no infrastructure set up, and the context depth, it can consume a lot of information. Right? But RAG is doing much better compared to the large context window in terms of reducing hallucination and have the latest data available, and in terms of cost, and have access control. So even in the million token context window, RAG is still relevant, right? In those three areas we just talked about in terms of cost, latency, as well as the relevant context, so that it will reduce the hallucination, as well as have a data freshness and auditability. Okay, so we'll come to the last part, just share some best practices in terms of how to scale AI safely in an enterprise. For building an external facing application, safety is really important. So that's why having grounding, guardrail, and filtering, and PII masking, whether it's a pre-LM and post-LM, those are very important. And this day, everyone is talking about agent, right? But you need to have a kill switch for the agent and make sure that there is a supervised layer with a human in the loop that really have some safety policy and trigger in place. Whenever certain things happen, you make sure that human can step in, whether it's a low model confidence score or high risk action, right? In the financial services. So you can build an AI agent to place trade, right? Execute your order. And hopefully that's the trade that then you need to make sure that it is satisfy your risk tolerance. You're not going to do some crazy high risk trading option if you don't have the risk appetite or if you don't understand the risk. And as well as certain area, if it's modify some of those safety policy in place, where the agent want to do everything, it's turn off those safety. That's where you need to have a human step in. And you need to have an evaluation framework, constantly evaluate how your system is working. In terms of the RAG system, there is a framework called RAGAS framework, really looking at the faithfulness, right? Whether the answer is grounded in the context that you provide, and the relevance, right? That's the answer, really answer the question the users ask. And then the precision is looking at your search part, the retrieval, whether the retrieval finding the right context. And there is a evaluation is normally, like the gold standards always have your subject matter expert really evaluate the right answer. But it's very time consuming, right? If you have a lot of data, it's impossible to have every data output to review by human. That's why you probably want to combine them in a hybrid approach to do evaluation, using LLM as a judge to do the evaluation as well. So I list those are the 6 key areas in terms of having production-ready RAG solution. The first thing is getting the right content, right? Called the semantic chunking. So not just automatically based on the length of the document, the automatic breakdown, but rather break it down by the meaning of the document. Right? Having the software tool to break down the document would be the last resort. So probably the best practice is still having your expert, whoever produce the document not just for human consumption, but also have in mind those documents will be consumed by AI, so that smaller amount targeted for each section, right, really have a good heading and cover just a small topic in the document. Don't have a giant book document, just throw the giant book for LLM, right? And have a step to optimize the user's query. User is really asking the question, waiting for answer. But when you interact, the first step, you need to search your vector database. The search, if you just use the user's raw query to perform the search, right? For semantic search, maybe work okay, but oftentimes you can always do better. So you're adding a optimization layer to optimize the query, translate that to a query that's better for the search engine performance. And then in the search engine, there's really, I think, three main components that you need. You need to have a semantic search and lexical search. Then need to have a good re-ranking algorithm. I mentioned using a small language model for the re-ranking model. You can start with just pre-trained language model. There's if you go to Hugging Face, there's a leaderboard called the embedding model leaderboard. There is one particular task called for the ranking. So that's where you can find some of those models can really perform well for ranking. And post-LLM, you want to have a guardrail for those that, especially for the external-facing application. For internal, if it's just for your company employee, probably the guardrail is not that important, right? But for external-facing application, this is really critical. And observability, you want to have a real-time tracing and monitoring, and have a full data lake capture the entire input and output for auditability. And doing a lot of analytics, right? So you want to evaluate how your system is performed. So you want to have those log captured in the, not just for 30 days. So probably for some of those real-time tracing, they don't have the capacity to capture the really long time. So if you want to capture 2 years of log, so some of those real-time tracing platforms, they don't have the capacity. That's where you need to have a data lake to capture those full logs. And have an evaluation, right? Post-evaluation, the offline, have a human in the loop as well as the system. Just looking beyond, probably the RAG versus long context window, this debate probably is not that critical. We've entered the phase how can we put the right content into the context for LLM? We call the context engineering, right? Whether you can build agent, give the agent this search tool so that it can automatically perform the search tool, find the right content for the LLM. But regardless of how you build a system, retrieval becomes a foundational layer for your AI application. Okay? So one of the ways to build this agentic AI is called agentic RAG. So thank you for your time. Happy to take any questions.